Okay, this video is going to be filling out the bottom flap of section 2 of your Unit 10 volume flipbook. We're going to cover three more shapes: the cone, a rectangular pyramid, that means the base is a rectangle. There are other pyramids like a triangular pyramid, but in this case we're going to cover rectangular pyramid, and then a sphere. So let's continue on with some of the same ideas that we used in the previous video. Let's take a look at this cone. You can see, class, that unlike the previous shapes, prism and cylinder, a cone only has one base. The base of a cone is always a circle. Okay, and we're going to go ahead and label the parts of this. Let's label this as the height, and then this distance here from the edge of the base to the center of the circle is going to be radius, or r. Alright, one more thing to note here to be very careful of. Sometimes in diagrams you're going to get a measurement for this distance right here. This slant height is what we called it in a previous video. Let's make a note for yourself. Do not use the slant height. The slant height as the height of the cone. Do not use the slant height as the height of the cone. If they gave you this dimension, you cannot use that as the height. The height is the distance from the base to the top of the cone, or the apex of the cone. Alright, so how do we figure out volume of a cone? It's actually pretty straightforward. First thing we look at is, what is the base shape? Well, here's the base. It's the bottom circle here. So the base shape of a cone is a circle. We already know how to find the area of a circle. We did it on the cylinder. The base area is the area of this circle, which is pi times radius squared. And then we take that base, we plug it into our formula. The volume of a cone is not the same as a cylinder. You couldn't say it's base times height, because that would be a cylinder. It's actually 1/3 times the area of the base times the height. We'll look at that a little bit more in class. Alright, let's take a look at a rectangular pyramid. In this case, we also have a height of the pyramid, the distance from the base to the apex, or the top of the pyramid. And then we have some dimensions for the base that look a lot like a rectangular prism. We've got length and width. Again, be careful on this. I'll make another note. If you are given the length of this edge right here, or one of these edges from the corner of the base to the top vertex, or the apex, you make sure you don't use that as a height. So let's put a little note here. Do not use the lateral edge as the height, or as the height of the pyramid. It's a common mistake, and a lot of times on diagrams you'll be given this length of this edge along with the actual height, and it's easy to flip those two around, so be careful of that. Alright, what is the base shape of a rectangular pyramid? Well, it says it right in the name. The base shape of a rectangular pyramid is a rectangle. And I forgot to do this, class. It's not as critical on these shapes, but I should still circle the height. Get in the habit of always circling the height. When you identify the height, circle it. That way you always know which dimension is the height. And I should have also shaded this base, since we're learning how to always shade the base of our shape. Notice again, the height is the one dimension that's not part of the dimensions of the base. And same thing here. So it's always the same rule. The height is always separate from the area of the base, or the sides or edges of the base. All right, what's our base area? Well, the good news is, this is a rectangle. We know the area of a rectangle is length times width. And the volume of our pyramid, thankfully, is exactly the same formula as the volume of a cone. It's 1/3 times the area of the base times the height of the pyramid. All right, last one, sphere. This one's a little bit unusual. Let's take a look at the sphere. We only have to know, really, class, one dimension, and that is the radius, the distance from the center of the sphere to any point on the sphere. So in this case, there is our radius. A couple other things I want you to note. Let's go ahead and label this. There's something called the great circle. Okay, the great circle it's the circumference at the middle. So if you want to know what the great circle is, it's the circumference at the middle. It's right here. I drew it for you so you can see it. It's the circumference exactly in the middle. It divides the sphere into two halves, and that's our next definition, which is hemisphere. What is a hemisphere? The great circle divides a sphere into two halves. Hemisphere is half of a sphere. Exactly 1/2 of a sphere. Remember, we learned semicircle is half a circle. Hemisphere is half of a sphere. All right, how do we find the volume of a sphere? Well, there's one thing about a sphere that's different from all the other shapes. There is no height, and there is no base. So for base shape, there is no base. And then as far as base area, it doesn't apply. There is no base area. All we need is the radius to find the area of a sphere. The volume, the volume of a sphere. The volume of a sphere is 4/3 times pi times radius. Now be careful on this, cube. Biggest mistake I see is students use this formula and use r squared. That's for area. For volume, it's r cubed. Last thing I want you to write down on this page is this note here. Remember the previous video I told you for prisms and cylinders, think of height as the distance between the two bases and not how tall an object is, because if it's turned sideways, it's not the height. The height does not look like how tall it is. Distance between the two bases, well, here's something to give you a heads up on with cones and rectangular pyramids. It doesn't apply to spheres, but it applies to these two. Think of height, or the letter H, like your own height. You would measure straight up, not crooked. So you would never find the height of this cone by measuring crooked. Just like if I want to know how tall you are, I'm going to measure from your feet straight up to the top of your head. Same with the pyramid. You want to know the height? Don't measure crooked along this edge. Don't measure crooked somewhere along this face. You're going to measure straight up and down from the base all the way up to the top of the pyramid. And sometimes, since you can't get inside of a pyramid, you're going to have to measure that from the outside. You're going to have to hold it up with your eye and just look across and figure out what is the distance from the base to the top of the pyramid. That's how you measure your own height. That's how you measure the height of a cone or a rectangular pyramid.